Welcome back. In this video, we're going to try to evaluate this integral of the sine of x minus x between 0 and 2 pi. We can solve this integral by using a change of variable by letting y be 2 pi minus x. Okay, we're going to use that here and solve the problem. But instead, we're going to use this change of variable here. So we're going to let x equal t plus pi. Note that when t is minus, or when x is 0, t is minus pi. When x is 2 pi, t is pi. And therefore, and dx is dt. Therefore here, this integral, let me write one more time, sine of x minus x dx. So here, this one is going to be the integral between minus pi and pi of the sine of what's x now? X is t plus pi minus x minus t minus pi dt. Okay? We're going to use many techniques or many properties of the sine function. First, the sine of t plus pi is minus sine of t. Okay? So we're going to use this one here. First, this gives us that the integral between minus pi and pi is just the sine of minus sine of t minus pi dt. Okay? Here we can factor out by this minus because sine is an odd function. So we're going to have minus the integral between minus pi and pi of sine of t plus pi dt. Okay, so here I can use one more time this property here that sine of t plus pi is minus sine to get rid of this minus here. So here, if I use this one as my alpha and this is pi, so I have the sine of this quantity plus pi is minus sine, and therefore I can get rid of this pi here, this minus here. So I have minus pi sine of t plus t dt. Okay, so now I can use something else. Okay, so here remember that when I have a function, the integral of f of x dx between minus a and a is 0 if f is odd. This one is an odd function here, and a is pi. So therefore, the integral between minus pi and pi of an odd function is 0. So this means that my integral is just 0. Remember, this is an odd function here, something like this. And we are integrating between minus a and a. So here I have a positive value, but here I have negative value. When I add them, I get 0. This is what's happening here. Okay? So here we used many tricks, and especially this idea here. Okay? And this gives us that the value of this integral is 0. Here, this change of variable is just the King's rule. Okay, so it will give us the same result. Try it. Okay, thank you very much.